Alright, so we've got a lot of programming background right now actually, and what I'm hoping to do is, with the knowledge we have with conditionals and logic and just kind of programming flow, I want to go through loops. That's the next topic, and I want to try to do it all out of the Arduino IDE rather than the PowerPoints. I think we're ready to go ahead and give this a shot. And I'll have maybe some of the subscript there to help you guys out along the way. But these really, once you get the concept of conditionals down and variables, this is really, I think it's a breeze, and I think you're going to be fine. So the first one I want to talk about, there's two types of loops we're going to be using, the for loop and the while loop mainly. And so let's go over the for loop first. So since our void loop is going to be running continuously, I want to ignore that for now, because I want to only have our programs run one time. Okay, so let's go ahead and and by the way, this is where having global variables and really locking down what variables are what is going to start to be important. Okay, you don't want to mix your variables. So let's go ahead and type up a basic what a basic for loop would look like. So you type for, and then there's going to be some, again, it's like all other, it's kind of like your conditionals. There's going to be a statement in here that well, it's a three-part statement that I'll show you, and then the for loop is going to loop through the code that we put inside of the parentheses after it. Okay, so with the for loop, one of the ways I like to do this is initialize and use the variables right in the for loop. Okay, so the for loop parameters, I guess you could say, the threefold parameters are as follows. You're going to start off with an integer x, and I could even declare it, I could give it a value in this first part, in this first declaration part. And each one of these is separated by a semicolon. Okay? Each one of these declarations, there's three of them. So the first one is we're initializing a variable that is going to define our for loop. The second part is going to be excuse me, the conditional. It's a conditional that if it's true, then it tells the for loop to run through the code. Okay? So a conditional such as x, so as long as x is less than 10, semicolon. Okay, so we have our integer x that we have established as 0, and then the for loop is going to check this. So before it runs, the first thing it does is it's going to initialize this, and it does this one time when it starts the for loop. And then every time you run through the for loop, but before the very first thing that happens is it checks to see if this second statement here is true. Is x less than 10? Okay, and then the last part of the for loop is the iteration. And what that means is we can modify the variable that defines our for loop so that eventually at some point we get a well-defined amount of times the for loop runs, and then it will exit. So for this example, we're just going to do x plus plus. And what plus plus does is it's an incrementer. You can do incrementing and decrementing in C++. So I could do something like C minus minus as well. That's a decrement operator. But plus plus, what that does is it's the same thing as writing the following code. X is equal to x plus 1. Right? This is the same as x plus plus. Excuse me, yeah, x plus plus. So that just means we're increasing x by 1. That's all it is. And you can also do stuff like this too, plus plus x. And there's different reasons for doing that. We can talk about that later. Maybe it's not as important, but it just changes when the incrementing or decrementing happens. So for now, we're going to have just the incrementing after the x. Okay, so And what this is going to do is, so again, before the for loop runs, it checks this statement. If this statement is true, it's going to run the code in here, and then at the end of running the code, it's going to increment x. All right. And here is a flow chart of what we're trying to talk about. I'll just keep this off to the side. So this, again, we're going to, so flowcharts show, well, they show the flow of how a program is running. So remember that, I mean, when our program runs, it's running from top to bottom. Or, I mean, I guess when you read in English, it's left to right, okay? So when the processor gets to this for loop, it's going to first initialize. It's going to do this first thing here in the first column here, this init. All right, so whatever you put here, it's going to do first. Then it goes to the condition, and it says well, I mean, you probably should have included the variable in your initialize, but if not, we'll talk about how to not do that. But it checks the condition. If the condition is true, the code block is executed, and the code block is inside the parentheses, and then the increment comes at the end. All right, so at the end of the code being executed, the increment is run. Increment or decrement, you could also decrement it as well. And then it goes back up to the condition, and if the condition is true, it runs through again. But if the condition is false, aka in our case, if x is equal to 10 or greater than 10, then it's going to jump out of the loop and continue on reading down the program. Okay? So let's go ahead and let's just do a proof of this to show you guys that I'm not lying or I'm not crazy. So we've got our serial begin. So we've already got our serial initialized, and we're going to go ahead and use that to just prove our sanity here. Okay, sanity check. So let's go ahead and print to the screen our variable that we're incrementing to make sure it's incrementing properly. Serial.print ln x. All right. And what we would expect is to get, we're going to start with 0 because the increment doesn't happen yet. It happens after this is executed, if this is true. So we'd expect to start with the 0 and get up to 9. And that'll be 10 iterations. And once we hit 9, running through here, this 9 is going to be incremented to 10, and 10 is not less than 10. X is not less than 10 when x is equal to 10. So it's going to then jump out of the for loop. All right? So let's go ahead and see what she do. And sure enough, we've got 0 through 9 printed out for us. Alright, so once again, variables initialized, flowchart back. For loop always has 3 of these arguments, and they are always separated by semicolons. Variables initialized, the condition is checked first and foremost, and if the condition is true, the block of code is run. After the block of code is run, the for loop runs the increment parameter, and then the condition is checked again to see if it's going to run through. If the condition is not true, the for loop is exited, and the rest of your program is executed. Very good. And honestly, that's basically all I wanted to talk about. Most of what I want to talk about. Oh, okay. So another thing I would like to talk about is the fact that the for loop should have, when you initialize a variable in this for loop, it's actually considered what we call a local variable. Okay, x is a local variable, and it's local. What that means is it's local to this for loop. Okay, it means you can't access x anywhere else in your program except for in this for loop. And once you exit this for loop, x is destroyed. Let's go ahead and see if we can print out x after the for loop. Alright. Name lookup of x changed for new ISO for scoping. Okay, I don't know what this error is, but I know that the compiler is not happy with us because we didn't initialize x globally. If we did something like this, x equals 0, then yeah, we can verify this and this will be fine. Right? Okay, but we just made a huge coding mistake. Can you point it out? The problem now is we've got an integer here called x and an integer here called x, which means that if I go ahead and say, well, say I say serial print x, how does the program know what x to print? Because this is a global variable, which means any part of the program can access it, whereas this contains the local variable x, which can only be accessed inside the for loop. So there's a conflict of interest here. There's no way your processor is going to know which x you're talking about. If I start saying, you know, if I do an x plus plus or x equals x divided by 234, how does it know what x is what? The answer is it doesn't. Okay, so you never want to do anything like that. And this is why global variables can get dangerous, because you can lose track of them easily. So once when we get into user-defined functions in a little bit, we'll talk about really keeping track of your variables and making sure you're using local variables as much as possible. At least that's what good coding practice is. So that is a little bit about local variables. And finally, I just want to show you guys that we can do a decrement. So let's do a decrement example. So we can initialize this something other than 10, or something other than 0. So we'll say integer x is equal to 10. We will say while x is greater than 0, run this. We want to run this for loop while x is greater than 0, and we'll do minus minus. Okay. And see what that gives us. Minus minus is the decrement operator, so it's going to subtract 1 from x each time, right? So if we open up our... Okay, and sure enough, we go 10 all the way down to 1, and when 1 was run through this for loop, so we printed out a 1 as x is equal to 1, and then once it reached here, it went back, it decremented x, so now x is 0, and then the for loop looks, it checks as conditional and says 0 is definitely not greater than 0, so I should not execute this for loop again, and it leaves. It moves on to the next part of the program. So that's a good start on for loops. Definitely more we can talk about, such as you don't even have to initialize a variable in here. If you have a global variable initialized out here, then you can. So if I say int x equals 0 out here, then I can just use x in here for x. X is greater. Let's just do this one real quick. This one last one. And now I should be able to print out. Let's see here. I should be able to print out after the loop. I should be able to check what x is. Alright, because x is no longer a local variable, x is a global variable. Global variable. Initialized. Actually, I'll do it out here, because Arduino doesn't like when you initialize in the setup sometimes. X is 0. We're using x now as our manipulating variable. And I'm going to go through and see if we can read the variable after the for loop happens. Oh, what did we get wrong here? Oh, I forgot my semicolon. Don't forget your semicolons, kids. What have we here? Okay, we've got 0 through 10 now. And why do you think that is? Well, it's because we started at 0. The for loop ran all the way until 9. And what happened when we got to 9? It printed out a 9, because x is equal to 9. And then it incremented 9 up to 10. And then the conditional was checked. And the for loop, the processor realized 10 is not less than 10. 10 is actually equal to 10. Duh. Okay? So the for loop jumps out of here. But remember, x is now equal to 10. So when we call it our serial print function again, outside the for loop, this is the next thing in line to be processed, our 10 printed out to the screen. Right? That's all there was to that. So yes, you can use globals in your for loops, but we're going to continue to talk about how to be careful with allocating memory and using variables and how to not screw up when doing that. All right, let's move on to the while loop. I think we've got a good intro to the for loop. The while loop is a little bit different and definitely worth talking about. All of these, there's a reason for all of these guys, and even if you don't see the immediate importance of them, they will come in handy from time to time and different scenarios, and you're definitely going to want to know all these little tricks, all these little tools that you can use to really optimize your programs and make them as efficient as possible. So the while loop. Where do I want to start? So basic syntax of the while loop is type while. There's a conditional, just like we've been doing, and there's a block of code you run. It's the same darn thing we've been doing this entire time, right? Let me just make it look a little better. So here's the code that gets run, and the conditional lies in here. All right, so what do we want our conditional to be? Well, if you want your code to run forever, what do? If you want your while loop to run forever and ever and ever, what would I put in here? As you could probably guess, remember that I could put the equivalent of true or 1 in here. So I could type while 1, or I could even type while true. Because remember, this code is going to execute as long as this conditional is true. This conditional as a whole. Right? So we could do while 1, but then our Arduino would be an infinite loop, which you don't want to do, because then you're pretty much not able to run any other code unless you unplug or reset or reprogram, whatever. So let's try something else. Let's go ahead and initialize a variable. Int x equals 0. Alright, we're going to do just boring stuff with integers for now. I know it's not fun. But we will get to some cooler stuff later. And it's also, I'm giving you guys the tools to use, but it's also up to you guys to be creative, to think of programs that you can make, to think of, this Arduino, the possibilities are endless. You can do just a vast amount of things and really bring your ideas to life. So don't be limited by what I'm teaching you. If there's something, other capability that you want to learn for the Arduino, go ahead and go on the Arduino reference website and look it up. If there's a project you have in mind, talk to me about it. Talk to some of the mentors. Ask us, is this possible? Is that possible? Can we make it do this? The answer is probably yes. And if it isn't an immediate yes, we can definitely find a way or find at least something comparable to that. Okay? So don't be limited by what we're teaching you here. These are just the tools to get you started. So we're going to go ahead and do that boring example again that we did with the for loop. We're going to say we're going to do the same thing with the while loop that we did with the for loop. So while x is less than 10. And what do you think we're going to put in here? X plus plus, right? So, oh wait, when we forgot, so we want to print it out to see that it's doing it properly. So serial.println, and we want to do x, right? So once again, the while loop is going to check the conditional. If the conditional is true, it runs this block of code, and it comes back and checks the conditional. And so it's actually a lot dumber. It's a lot dumber than the for loop, right? It just has one check, and if the check is true, it runs through, and it just keeps doing that. So it's kind of blind. The for loop is nice because you can specify how many times you want something to run, whereas the while loop is going to wait until whatever you're running is not true, and then it's going to jump out. So there's definitely different uses, and they're much more practical in different cases. Where well, you'll see when we do more applications and when it becomes apparent when to use which one. So that should be it. Let's go ahead and upload this guy. We don't need this anymore. Save changes. No. Okay. What do we got? Sure enough, same old thing. 0 to 9 when serial print. So when x is equal to 9, it's here. When you increment it, it goes up to 10, and 10 is equal to 10. So the while loop parameter is false, and the while loop pops out of there. Guys, that's basically it. That's what I wanted to teach you about loops. There's definitely more to it. There's this thing called a do while, which you can look up. It's also useful in different situations, or ask a mentor about it, and we will help you out. So there's little other tricks you can use, and different ways to use these loops better. But that's the basic idea behind loops. It's not really too bad at all. It's all based off these conditionals. You just have to remember true and false, basically. If you can play true and false, you can play around with loops. You can play around with conditionals. You can pretty much program if you know how to do true and false. All right? Awesome. All right, I would love to teach you about LEDs also, because that's our next demo. Our next challenge is going to be to light up some LEDs and do some fun stuff. But I found some pretty cool videos that are going to teach it a heck of a lot better than I am. So the next videos in your playlist are going to do an intro and teach you a little bit about light emitting diodes. Enjoy.